another episode of AKS Anything. Today we're here with Robbie Zhang, who's our engineering manager, and you'll be excited about what his team is working on because he's responsible for one of the less seen parts. You interact with it every day, but you might not know a lot about it, which is a control plane, where the Kubernetes API server and etcd and all the components are, and also what we call the management plane.
Yes.
Which is, you might know them with add-ons and integrations. So everything that's the AKS system managed, like the add-ons, those are also on Robbie's team as well. So I'm excited about this. And what has the team been working on over the past few weeks and months?
Always a lot of things to do.
Of course, always busy.
People are thin.
Yes, absolutely.
So thank you for introducing. So basically, the manager of three categories, mostly customer control plane, mostly API server, TCP, and the delivery of the control plane charts. Now there is another team in Australia is responsible on the monitoring and the scaling of the control plane part.
That's something I bet people are really keen on. Monitoring and scaling is always a top asked question in a lot of our conversations with customers and users.
Yeah, and they will also get into the alerting, RHC alerts, and also internal ICM alerts for these components.
So how we get alerted internally for any issues.
Internally and also externally.
Also how customers themselves can get those alerts.
Right. That's right. So, and the second section is about what we call management plan. So people always say add-ons. Yes. So I want to make it management plan so that to be clear that this team actually is responsible to deliver these add-ons and have basically help the add-on team to set up release pipelines or help them to monitor the delivery QoS and also some framework to monitor the add-ons runtime quality.
Right. That's something a lot of people might not know yet is that our add-ons actually ship differently. Very recently actually broke down in Release Tracker so that you can see the different pipelines for the different add-ons, which before were actually, you see that all in the joint release, but now for more flexibility of both your team, but also each add-on on your team.
That's right.
They're broken down so you can actually get updates for these different components as well as your traditional AKS weekly releases or the node releases separately in Release Tracker. The link right here actually shows you all of those components as well with Kubernetes versions and a lot more of those. Okay, and so the management plan goes beyond just having those add-ons. It's all about what surrounds it, like managing them, the infrastructure that is required that people typically don't see.
That's right. And with the support from observability team or from the AKS Airlock team, so that we can collect all the metrics for monitoring.
Very good, very good. Two good suggestions for next AKS meeting.
Yeah. And then the third category is about planned maintenance, which is allow the customer to configure the time when they want to get the patches for their control plane, for the add-ons, and also their node pools, VHDs, or even cluster upgrade.
So I think a while back we actually had Ye come in and talk a bit about the OS security patching as well as the maintenance unit and all the things that are coming there, all the different integrations. So that's a very key area for customers as well. And that third category is super important.
Yes, and this team will also own already have onboarded some of the notifications which emitted from this automatic upgrade pipelines, maintenance pipelines, so that customer can subscribe and be alerted about, there is something will happen in my cluster and what's the result.
Exactly.
Eventually I want to build it to also accept like the control plane upgrade and also the add-on upgrade. So one of the customers' feedback is about, we don't know anything. Like, you know that the release tracker thing, right? Yeah. But they don't know that when this change will get into my cluster.
Right, because so they now know what, after, but when will it?
Yes. Right. That's the thing that we want to be more transparent.
Absolutely. It's already pretty unique how we can deliver such granular maintenance windows and such granular observability and release tracker And I love that we continue to kind of build upon that and provide even more transparency and more, because it's how users are able to plan for their own maintenance, for their own changes, create their own pipelines to see those changes. That's really good.
Yeah.
So what you've been across all that sea of opportunity, what have you been working on with the team recently?
Recently, most opportunity comes from for the CCP part, it's the large cluster support and also customer transparency.
Okay, very good.
So why control plane is can be a bottleneck for the large cluster?
So maybe let's start there. So what is a large cluster?
Yes. Okay. What's a large cluster? So it will change going probably like if you talk about 5 years ago, 100 node is a large cluster.
That's right. That's right.
And
so remember some of the earlier limits that the Kubernetes upstream scaling limits were about 100 nodes, and that grew up to
1,000 and grew up to 5,000, and then last year Google announced 65,000 nodes.
That's right.
That's super large clusters.
Right.
So our current scope currently is working on support 5,000 nodes, but to support like more than 1,000, depending on the workload. To support 1,000 nodes, it's already a large cluster.
Okay, so that's a trademark. Yeah. Above 1,000 large cluster, for everybody that was just like thinking that their 500 nodes is very large.
And there is a condition,
okay.
Of course. It's not only about the cluster size, the node count, but also the workloads, the DNS pod running on the node.
Because you can have like a smaller than 1,000, and maybe there's less kubelets and less components in the node, but maybe you have more components in the nodes doing things like calls to the API.
That's right.
Right.
There are several popular solutions which you have to run a DNS pod running on every node, right?
Right.
To achieve some, to understand the whole world of the cluster and then do its job. So all these components need to send either like periodic list or establish a watch list informer to get the resources that it's interested. So the more components,
it's almost like doubling every component you install. There's like
that's right. Kind of like so a lot of time we think that it's kind of you need to design well so that you can support running this feature on a large cluster.
Right.
Small cluster, you cannot see it, but when the cluster size grows, you have more resources, and you have more resources to be read or fetched back into the node, then it's more impactful. So sometimes it's even like an exponential problem. So basically, the larger the cluster is, then you need to allocate exponential resources into the
so it's not a proportional thing that you can just set in, okay, I have a few more nodes, I get a few more. Okay, so it seems like our scaling is a bit more complex than that.
So that's the challenge.
That's exactly it.
So from the control plane side, what we want to improve is about how can we scale our control plane components and also restrict some bad client. So
behavior,
bad behavior. Because it's anyway, customer can deploy anything into the cluster.
Correct.
We don't know what it will do, right?
Correct. And it could be, we have issues in the past, right, where there several projects where had like leaks on the watches or the lists, and if you can kind of almost have a denial of service done to yourself, then regardless of how much we scale, that's always going to have if you try to by mistake with denial of service to your own API, that's always going to be a problem.
Right. Yes. So anyway, for the control plane or large cluster support, it's always like we scale out on the control plane, and the other side is about how to detect and protect from customers' bad applications or bad behaviors deploying to the cluster. Right.
So those two things are going to be helping both refine the scaling, right, so that we respond better to, let's say, legitimate scaling, and then the other one protects so that sometimes we might not even want to scale, just a bad behavior, we just want to throttle it
or warn the customer saying, oh,
warn the
this
customer,
component probably will becomes the bottleneck to either to further scale your cluster.
So even warn them oftentimes, and that's something that we could do before
before it's getting to the tipping point.
Right. Yeah, customers would definitely love that type of warning for sure. That's something that we've heard in past videos that requested this exact kind of topic. That's nice. What else?
We are innovate from the management plan side. We are innovate another iteration of delivery framework, Inno framework. So basically,
what's the Inno framework? Tell us more about it.
It's a controller similar to a lot of like popular components, but often like the helm controller or the Argo CD. However, it's optimized for the AKS internal component delivery.
That's interesting. So it's something like Argo CD. I bet
it's
those
similar
Argo
to Argo CD. Basically, it's like a controller mode.
So is it open source?
It's open source.
Oh, cool. So curiosity. So I presume it's to help us deliver some of those components. Why didn't we just use Argo CD?
There are different things. So no matter Argo CD or helm controller, the major problem that they didn't solve is about how do you connect your customized data and the resource you want to deliver. You anyway need to build something like a composition or adapter between your internal data model to the charts defined values. Fixed value. So for Inno, we actually
that seems specific. That what we have, right? Because we have a data model that actually matches that. So it feels like from a lot of the user's perspective, they're just deploying applications just as if that's a simple thing. And so that tool has it. But in our case, we actually need to make sure that a specific information in our data model actually is being passed, and that's what's there. Right?
And for this part, the nature of AKS is that this component is contributed and by the solution owners, right? It's not
fields that actually are there,
right? They not only need to deliver their application images, they also need to understand what's the AKS internal data model, what's the contract, and how do they convert into the model or template it into the flat model of the resources.
Right.
So and AKS actually Microsoft have the SDP release process. By also we
talked about it recently. I think it was one of the first ones. But just to remind folks, the SDP stands for Safe Deployment Process, and it's a process that you might know from our release tracker and more of how we do region by region, different rings and groups to safely and slowly release across all the Azure regions. Yeah. So we have that, and how does that plug into SDP?
So we need to build the pipeline,
right,
to deploy the stuff region by region based on the AKS SDP process, and also respect the last part, the maintenance windows, customers
full circle
set for that right to roll out. So that's the pipeline that I know that maybe Argo CD have something, right? But we do not need a lot of components that Argo CD do, but we want to get a lot of controls because all these stuffs, the manifests, the add-ons, or something's delivered to the underlay and the overlay, they are fully managed by AKS, right? They're for the popular ones. A lot of times we find that those tools is still developed in a CLI command, right? If there is anything wrong, then it will ask for human intervention.
Right.
So
which is unacceptable in our case, right?
Yes, it's unacceptable. We have managed like hundreds of thousands of clusters all over the world, and also we need to manage Fairfax, sovereign
all
clouds,
different cloud types that we have across.
It's a small engineering team. We think that we should take the ownership and make it easy.
Absolutely. And a lot of those cases, when you're thinking of scenarios like you want to deploy something, if something maybe fails, you expect a human to intervene, maybe run the pipeline again, etc. And for those tools are perfect. In cases where you expect the system to self-heal, be able to match what it's there, take action, match what's on the data model. You need something that is very particular to that point. If you do have that use case, and as you heard, it is open source. Feel free to contribute and use it as well. I'm sure the team would be glad to walk over that as well. And we can have eventually a bit of a deep dive on email. But you were going somewhere with it, so we're doing a lot of the innovation there. What else?
Probably last part.
Okay.
Hopefully not the last part. The DNS.
Oh yes, the topic that a lot of folks have asked in the comments.
So a lot of things when you see, so DNS actually is an interesting topic. When you see application issues or network issues, the first thing you will hit is actually about the DNS, right? A lot of things surfaced out as the FQDNS cannot be resolved to the IP, or it's like intermediate failures or whatever. So the main reason for that is the nature of UDP protocol, because it's connectionless and everything is client driven, and it's bi-direction, right? The UDP packet can be dropped in the forward direction, can also be dropped in the reverse
at any point.
Yes, right. So there is another project we are preview, hopefully when we have this video.
Sure, very good.
It's about it's called AKS Local DNS.
Okay.
Yes, so it's leverage the idea about the open source project, know the local DNS. However, it's an optimized solution that can help to build a DNS cache in the Linux nodes, and also so for the Kubernetes itself. Because know the local DNS, it's really as daemon said, it cannot be used by the Kubernetes, which is the agent.
Right, because the Kubernetes is running as a binary underneath.
Yeah, that's right. So we build the ultimate goal for this one is improve the DNS resilience on the node, on all, so that all the process, no matter it's the systemd component or the pod or anything that agents running on the node, to take advantage of the DNS.
Because ultimately everything ends up leaving the VM, especially if you need to go up to an upstream DNS server. And so optimizing all of it ends up being better than maybe just optimizing some of the container-driven calls. Typically, that's what you want to do. But there's actually a ton of more things under that can, let's call it be noisy neighbor to all the calls going sent to a potential upstream server like Azure DNS.
Yeah, that's right.
So what's the solution about? How's it going to help?
So in a nutshell, so basically we build a DNS cache layer on every node. Okay. It's an optional feature for the customer.
Okay, so I can turn it on.
You can turn it on and turn off. So with that one, then we will start a core DNS process on the node, and if the request is sent from the node, then it will go through the DNS, the VM DNS server, or the subnet DNS server directly. If it's a cluster sent from the pod, then it will go to the core DNS. And the other thing is, because
so regardless, so we send every request, whether it's from a pod or a system component, goes through this cache, and then depending on where it's sent from, it can then be redirected to either the VM upstream, VNet upstream server, or corresponding if it's a pod for core DNS.
For core DNS, that's right.
Okay.
For the cluster core DNS. And the other thing is, we are able to change the protocol.
Oh.
So although your application send the UDP protocol, we will send the TCP protocol to the cluster DNS or to the upstream DNS. You can configure that. So TCP, because it has connections and
maybe you're using your own server, your server doesn't support that, but if it does, you can.
Yeah, you can do that. It's more reliable, I would say.
Of course.
Yes, of course there is some penalty on the latency.
Yeah, you trade off latency for reliability. Yeah,
yes, and some resources, network resources
Okay, good.
connect.
I was going to go to that. So how much does this cost the user? What's the trade-off of using this?
Okay, so usually I think we have some benchmark testing and
Okay.
stress testing. So probably regarding the CPU memory usage for this component running on the node, it will consume probably less than one CPU core. Hopefully it's just half, 500 millicores. The memory, depending on how many DNS caches you want to maintain in your component.
How big is
So
cache
a
is?
lot of time that we get some internal, external customer feedback say, oh, please make sure that you can use the cache for up to 24 hours in case our DNS server is down or the Azure DNS is down.
Yes.
Right? So depending on how many records you want to cache, you can set that. And also DNS,
that's configurable.
it's configurable.
Okay, good.
How many records you want to cache.
That gives a lot of the cluster admins, a lot of the operators, even developers, if you're are optimizing for your application, a lot of controls. So beyond what you would get, what I would assume pretty much by default, if you just enable that and just using the default settings, you can then go and be really customized based on it. That's really cool. I'm sure a lot of folks are excited to go and try out the preview of this feature very shortly. All right, thank you very much for this. Well, I have one more question. Maybe I think it's been a long episode, but I want to ask you one more question, which is, what are you excited about for the future? We discussed a lot of topics that we've been working on.
Of course, AI.
Right.
Right, a lot of things in my mind. For example, like custom control plane scaling can take advantage of AI and add-on scaling.
Right.
Probably a good project for AI plugin to predict or like to give the customer good recommendations.
Right.
And also even like for the idea about the DNS caches.
Right. Try to optimize it. Yeah, that makes a ton of sense. Yeah, just trying to use AI to gather all the existing information, try to do some predictive.
So basically, plug the AI into our system to make it more intelligent in scaling and serving the customers.
And always more intelligent, more managed, less work for the user, less work for us as well, to enable us to do more things for the user. Well, thank you very much, Robbie. This was great. Appreciate your time having me here. Thanks all of you for watching. As always, like and subscribe to our AKS community. Don't forget to tell us what you like the most about the session and what you'd like to see on future sessions. What are your questions for AKS Meeting? See ya.